In this video, we're going to be looking over my single script architecture module loader, as I've made several changes over the past few months that I believe necessitates a new video explaining how to use it. So that's exactly what we're going to do. Do you need to use a module loader? Absolutely not. You can structure the scripts in your game however you want. But if you're interested in learning about single script architecture, then you've clicked on the right video. All you need to do is grab the module loader from the marketplace. Link will be in the description. And once you've got it, you can just click it and it will insert automatically into the workspace. We need to do a little bit of setup. So what we can do is open this up, and there's a few models in here that we need to ungroup into their respective services. So obviously this one, ungroup in replicated storage. So we're gonna put that in replicated storage and then hit Control U. There we go. I'm gonna grab this one, put it in server script service, Control U. And then this last one, we're gonna put down here, starter player, and then specifically in starter player scripts, and then Control U. And then we should be good to go. So basically what this module loader does is that you get it required from a single server script and a single local script. So here in server script service, this is our single script responsible for handling all of the server-sided logic in our game. And then this is going to be the local script for all the local or client-sided logic in the game. What this module loader is going to do is that when you call the start function, you give it a list of containers in which it's going to look for module scripts to require. So it's going to go through require all those module scripts. It's going to do that once on the server side, and it's going to do it once on the client side. Now, you're not only limited to just passing containers inside of here, as you can also use the collection service and tag specific module scripts to be required, loaded, initialized, whatever, by the module loader without having to have it within some particular container. And that gives you a lot more creative freedom with how you want to organize the scripts in your game. You can basically think of these modules that this module loader is going to be requiring as your own custom services. So for example, by default, the container for the server is going to be underneath the start script. So I can just throw a random module script in here. This is going to be my service. I have a whole bunch of templates that I have. Specifically, I have a service template. And all it's going to be, these aren't here, so we're just going to delete these for now. But basically, all this needs to be is just a table that has an initialize method and a start method. And these two methods are optional. You don't need to include it. But basically, what these two sections are going to be for is the order in which things happen with your modules. So the first thing that's going to happen is all your modules are going to get required through the require function. And then after all your modules get required, then they're all going to be initialized. So every single module is going to have the initialize function called. And then once all the modules have had their initialize function called, then we move on to the start function. And then all the start functions get called. And then boom, you're done. Module loading complete. Now you might be a bit curious on what should go inside of the initialize section and what should go inside of the start section. The initialize section should be for initializing basically connections to events. Maybe you have remote events, bindable events. Maybe you need to listen to attribute changes so you get signals. Whatever you need to listen specifically for events, you should put in your initialize section. So like this could be like, I don't know, listening to the player added events. So you get the player service, player added, connect a function in here, and you get a player, handle all the players in the game. And specifically, we also need to make sure that if there's any players that are already in the game by the time this initialize function runs, we handle them as well. So, you know, common pattern is you create a function on player added, you connect on player added, and then you also go through all the players, in players, get players, and you can kind of do the same thing of on player added and put a player in here. Usually most of the time people do task.defer, or you should be doing task.defer because it doesn't need to run like immediately because the player's already in the game. And then you can do your initialize or setup for whatever players you have in the game for whatever this module script is doing. We're just going to call it my custom server service. And then you can really design these modules however you want. So if you want these modules to basically be like your own custom services, you could even make events or signals for your module. So like maybe you have some kind of like my public signal here or whatever. Maybe you have a signal implementation or a signal class, and you can put your signals in the module. So that way other scripts in your game that require this service can access the signals. And maybe you have other methods in here like get some doodad for players or whatever. Like you can just design this just like you would a regular Roblox service. which makes it kind of cool. This module loader also has a bunch of other neat settings inside of it. So if we look at the properties for it, we have some attributes. By default, we're going to have all of these enabled and with these values. So this attribute, client wait for server, is going to determine whether or not the client should wait for the server to finish loading, initializing, and starting all of its modules before the client starts doing anything. So that's enabled by default. We have this one called folder search depth. So basically what this does is when you give the module loader, when you call the start function and you give it your containers, this is going to dictate how far the module loader is going to search for modules in. So as a basic example, let me just create a folder in here. And let's just say this is some container with my services. And we throw some modules in here. So let's call this service A. Maybe we have another one. This is service B. I really need to fix this because I don't have these in here. Let me just delete these real quick. So service A, service B. And then let's say I had another folder inside of here that had some other stuff in here. Maybe there's some other modules in here. So we could say like this is other module, whatnot. Now by default, if we were to pass this container, some container with my services, and we have the current attribute on the module loader set to a folder search depth of 1, it's only going to require the first or direct children of this container. It's not going to go inside of this container and look inside of here for children in there. But if you increase the folder search depth, then you're increasing how far the module loader is going to be looking through these folders to find modules to require, initialize, and start. Now it's only going to look inside of folders. So if you have a search depth of like 500, but you have like some other instances in here, like, I don't know, for example, let's just say we had a configuration instance in here and there was a module script in here. It's actually not going to require this module script because the modules need to have ancestors that are folders that lead up to the original container that was passed. So if there's no folders or it doesn't directly lead to the original container that you pass to the start function, it's going to ignore it. Now, if you don't like that behavior, you think, hey, I need to change that, then inside of the module loader, we have a start custom function, and this allows you to pass it a predicate. So it's called shouldKeep. It gives you a container, and then it tells you, hey, there's a module script I'm trying to require. Should I require it? Should I not require it? And you get to make that determination if you don't like the default behavior of the start script. And of course, there's also some other neat functions in here. So you can get the timestamp of when the server loaded. If the server is not loaded yet, though, this is going to error. So you can check if the server is loaded. We can also wait for when the client loads. So it says yield until the client has loaded all their modules, returns true if loaded, or returns false if the player left the game. You can call this on the client or the server. We can change the settings for the module loader as well. So by default on the module loader, all these attributes are going to be stored inside of a table inside of the module loader. And maybe you want to change it for some reason during runtime or whatever, like we have up here. You can totally do that. You can change different settings for the module loader, like folder search depth, yield threshold, these other stuff. Let's actually look over these other settings. So we have a loader tag and use collection service. So this is going to determine whether or not you have collection service support for your module loader, and you can define what tag you want. So when you have a module, like for example, my other module, and if I were to throw a tag on here like load module, now this module is eligible to be collected by the module loader, required, initialize, setup, all that fun stuff, because it has the load module tag on it. You can of course change this tag to something else if it conflicts with something, or you can just disable it altogether if you don't want the collection service stuff. The next setting here we got is VerboseLoading, and basically what that's going to do is it's going to spit out a crap ton of stuff in the console that basically tells you the process of things being required, initialized, and started. If you don't want all of that garbage being printed out into the console, you can disable it. We'll see this in a minute. And then we have this last one here called YieldThreshold. So when you have your custom services with your initialize method or your start method, you should not yield inside of these functions. If you do yield inside of these functions, you're going to be stalling the module loader from acquiring or, for example, initializing anything else it needs to initialize. So if I had like a task.wait of 10 seconds in here, if my service A got initialized first and I still needed to initialize my service B, well, too bad, I gotta wait 10 seconds. And basically this yield threshold determines how long we need to wait before the module loader starts printing out warnings into the console saying like, hey, this service is taking a really long time to load. So as an example, we have a 50-second wait in here for service A, and then we just play the, just test the game here. So we got an error somewhere as well. Uh-oh, I've got to fix that. Can we try this again? You should be able to see the verbose loading there as well. So let's try that again. Okay, there's our verbose loading. You can see loading modules. Here's all the modules being loaded, initializing, starting, and then as well as what's going on with the client. So loading modules, initializing modules, starting modules, and loading finished. Actually, it looks like we did not require these modules, and that's probably because I didn't pass it to the start function. So let's do that. We could do script.parent, just for now, some container with my services. Okay, so now it should go through here and require these services. So if we go and play, okay, we are stuck right now on initializing module service A, and nothing's happening. And eventually, 10 seconds later, we should get a warning in the console. There we go. The init for module service A is taking a while. So far, 10 seconds have elapsed. And it's gonna sit here and it's gonna keep printing this every 5 seconds, as long as service A is taking a long time after that specific yield threshold. And this can basically give you a heads up of like, hey, something's wrong with one of your services, you know, you should fix it. So that's what this warning is for. And again, if you don't like this verbose loading either, because this will print on the server side and it'll also print on the client side for all the clients that join your game. If you don't want all that stuff popping up in the console, just disable verbose loading. I document a lot of the features for the module loader within the comments. So if you open up the module loader, I have everything documented in here. We have some other cool features. So for example, if you had a module somewhere, let's say it was in replicated storage. Let's say this is my service C. We have service C in here, and let's say service C has a load module tag. Now, let's say for some reason, I only want this service to execute on the client side, right? Maybe I want to store my modules in replicated storage inside of some kind of container, or I have the load module tag, but hey, this is only a client, this is a client only service, okay? Server, don't touch this. So what we can do is we can add an attribute. We could say client only, throw a Boolean on that thing, hit that check mark, and then we should see that in action. So let me get rid of this redundant yield. Now let's test, and let's see. Okay, we got service C right here. So you can see on the client side, we load module service C, we loaded it, initialized it, and started it. And if we go look on the server side, you're gonna see that, hey, service C doesn't show up anywhere on the server side because we added that attribute. Now another cool feature with the module loader is the ability for you to relocate modules to other places. So basically, if for organization purposes, you had some kind of complex system, right? And in this complex system, you had a module. This was responsible for server stuff. And you had another module. This was responsible for the client stuff, whatever. Typically what happens is that you do not want exploiters or people who look at your code by decompiling the bytecode of these module scripts. You don't want them to steal your code. And if your server code is inside of replicated storage, inside of a module script, that means any exploiter can steal your code, which isn't great. If you don't want that to happen, then I've got a solution for you. We can add an attribute to this server stuff module. We could say, hey, I want to relocate to server script service. And something cool will happen when we do this. So we're going to enable that. And then we're also going to make sure that we have the load module tag. This is server stuff as well. So just as a precaution, I'm going to mark this one as server only. And this one we're going to mark as client only. Make sure I spell it right. Oh, where'd my attribute go? Must have hit the wrong button. Crap, I didn't want a number. Client only. Boolean. Okay, great. So we're gonna test here, and we're gonna see that everything should have happened normally. So there we go. We have server stuff, loading module, loaded module, initialized it, blah, blah, blah. And then we also did the same for the client stuff. If we open up replicated storage and we look at our complex system, you're gonna notice that, hey, server stuff is still here. I thought you were supposed to relocate this, and I did. Because if you open up the script or this module script and you look at the code for it, that's what the code is. So this module now acts as a pointer that basically says, hey, the original module is inside of server script service in a relocated folder, and basically what I'm doing is looking for it and requiring it and returning it. So that means if you had other services that required this module inside of its original storage here in replicated storage, or its original location, it's not going to have any problems because you require this module, but it's still going to point you back to the original one. So if we look on the server side and we open up server-script service, here's our relocated modules folder. When we open that up, hey, there is server stuff with the server-sided code inside of it. So there you go. Now you can hide your code from exploiters during runtime, but inside of Studio, all of it's bundled together within the same location. So that way it's kind of nicer for organizational purposes. Now, obviously, you want to be a little bit careful with this relocate system or relocate behavior, because if you had any like children inside of this module for some reason, and you needed to access these children somewhere else, you're not going to be able to do that properly because the module gets relocated and placed inside of server-script service. So if you're going to have children for this module and you need to get access to those children, you have to do it in a few different ways. I mean, one way you could obviously just be able to get it through the service itself. So you could have references to those children within the script, and then maybe you could create some like getter functions to get whatever children you want. That could be a solution for it. You just need to play around with it, but that's just a precaution you need to take when you're relocating these modules. As well as, let's say you're using require by string. So let's say there was another like shared module in here. I'm just going to call it shared module. And let's say both the server stuff and the client stuff need to use this shared module. Pretty commonly, if you have this stuff bundled together within the same folder or the same container, when you need to require that stuff, you would use require by string. So if I wanted to get shared module, I could do it like this, where I index for the parent and then I get shared module. And it might be tempting to do the exact same thing on the server stuff side. But remember, when this module gets relocated and placed inside of server-script service, when this code runs, the parent is not going to be complex system anymore. It's going to be the relocated modules folder inside of server-script service. So you can't use require by string here. You need to actually require it through its normal path. So if we want shared module, we're going to have to be like, okay, I got to go into replicated storage.complexsystem.shared module. That's just another thing you got to watch out for. Now, if any of your services error at all, and for example, the initialization section or the start section, or even when you require it, the module loader handles that and it will print out a warning into the console of like, hey, something bad happened in the initialize function or the start function or whatever. So for example, in the initialize function for my service A, let's just throw out an error like, oh no, something bad happened. And if we go and I'm actually just going to run the game because we only need to do it on the server side. We're going to see, there we go. Failed to init module service A. Took that much time. And then we get our full stack of what the error message is. Oh no, something bad happened, line 36 throughout our module loader. So there you go. Now you have the ability to handle errors that happen in your services, and it's not going to screw up everything. It'll just print out a warning, handle the error, and then it'll continue going on through stuff in your game and initializing and starting other stuff. But it'll print out those warnings when they happen. And even if you have VerboseLoading disabled, it will still print out when these error messages happen. Another feature with this module loader is the ability to isolate module scripts inside of their own actors so you can run code in parallel. And it looks like I actually forgot to document that in here, so I could just add it real quick. We have a parallel Boolean attribute, and what this will do is it basically relocates the module into its own actor for running code in parallel. There we go. So for example, let's say I had some kind of system in here. I don't know. Let's just throw it inside of replicated storage. Let's say this is my parallel. Oops. I need to make a module script first. Let's just say this is my parallel service. I'll throw the service stuff in here as well. Basically the exact same setup. You're just gonna have initialize and start function, but inside of here, because this is going to be placed inside of an actor, let's throw on the load module tag, and then let's add the parallel attribute. This needs to be Boolean true. Because this is now a parallel service and it's going to be placed inside of its own actor, that means it's safe to connect to events in parallel. It's safe to call task.desynchronize to have code run in parallel. I I mean, parallel luau doesn't have a lot of use cases yet, so would you ever use this? Probably not, but hey, it's there if you want to use it. So let's go to playtest the game, my parallel service. And actually, I think it's going to be doing it on both the server side and the client side, right? Yeah, so we have it happen on both server side and client side. So you can tell which one's parallel because it says loading parallel module and then initialized parallel module and started parallel module, and it is the same thing on the client side. So let's actually look for my parallel thing. Actually, it doesn't relocate the module. My bad. I don't even know the logic of my own module loader. What it does is that the code that executes the initialize and start function is being executed from a separate script inside of a separate actor. So actually, where is this actor? Actor. So yes, I can see that I have an actor here that has required my parallel service. So this goes in here and it requires a module, initializes the module, starts the module within this actor. Now, because it's in a separate actor, you need to be a little bit careful, because if you were to require this parallel service elsewhere, let's say you're requiring this parallel service from a separate actor or another script, because these are in separate actors, that means they're in separate, most likely they're in separate virtual machines, which means that the caching capabilities of the require function, because when you call require, it says returns the value that was returned by the given module script, running if it has been not run yet, and then basically this function caches, so the module script only runs once. But if you're in separate luau virtual machines and you require some kind of module from different actors, then you're going to have 3 different copies of the same module script, and you're not going to be able to share information across them because they're in different virtual machines. That's just another limitation of parallel luau that makes it hard to work with. So you need to be careful of that. If I go and I switch to the server and we look inside of server script service, here's our actor as well. And then there we go. It required my parallel. So it doesn't relocate the module. My bad. It requires the module from another script within its own actor for executing code in parallel. There we go. Accurate description. Thumbs up. So a way you could see this module loader being used in an actual game is this game I'm working on, Clothing Factory Tycoon 2. We have the same setup where we have a start script in server script service, and then we have the same thing in starter player scripts. We have a start script inside of starter player scripts. I don't do the thing where I put children modules. That's because I have these scripts created as packages, and I don't want to have a bunch of like weird modifications happening. I want to reuse these scripts across multiple different places because they basically do the exact same thing with how we have our game set up. So instead, I have all the common services and things that I share across multiple different games in a folder called Modules Universal, and then any game-specific systems or things go under this regular modules folder, and then I just kind of organize it into the sections that I need. Most commonly, I'll have a section specifically for specific services, so all of these services get required by my module loader, and then I have another folder here called Systems. This container isn't required or passed to the start function for my module loader. So what I have to do with these systems is set tags on the modules, which is fine. So for example, we have like some setup modules that do some setup for different things in the game. So like this is setting up for boosts and whatnot. The reason why this is segregated from where it was inside of replicated storage, or I don't have it bundled together, because I added that relocating feature after I made this code, so I just never bothered to move things. But maybe I can show you a better example. Like if I go into modules and I go into systems and then I go down and let me see if I could figure out which one's yes, the checkout registers. So I have a client service for checkout registers and I have a server service. They have slightly different implementations, but they house very useful functions for client-sided stuff and server-sided stuff. And because I don't want exploiters looking at the server-sided code for my checkout register server service, I relocate this module to server script service, which is great. And then of course, inside of these modules, I have my same thing where inside of where's my initialize function? Here's my initialize function. All I'm doing in the initialize function is just connecting to a bunch of events. So here's an event that I'm connecting to, which is specifically a remote event. I'm connecting to the player moving event. I'm connecting to a server event for another remote. Here I am adding an observer to observe tycoons in the game. Technically, you could migrate like observers into the start function, but I'm just doing it here in the initialize function because this observer runs the code in here deferred. So when it observes the initial values, it does it defer. If you ever seen task.defer and how task.defer works, I got a video on it. Check it out if you haven't already. But that's basically what this does. It's just basic initialization stuff, basic setup. Most of the time, I usually don't have a start function unless I have something like maybe an infinite while loop that runs some kind of logic that constantly needs to happen. I'll throw that within the start method. But most of the time, my setup just happens in the init method. As you can see, I have the creative freedom of organizing these folders however I want. I just throw things in folders. I throw modules together in here. And then anything that these systems share. So like I'll have like this network that stores a bunch of remotes that get created during runtime. Obviously, the client logic and the server logic both need access to this network, so I store it in the same folder. This, of course, gets relocated, and then the client setup does its client setup stuff, blah, blah, blah. I have it all in folders, and there's really no right or wrong way to do it. It's just you figure out how you want to organize the code in your game, throw folders together, tag stuff the way you want it tagged with the module loader. You can restrict different run contexts if you need to. And then I also have some shared systems. So like I use the run service to determine whether or not something's running on the server side or the client side, which might not be a good way to do it because it exposes both server-sided code. So like run services server, there's server-sided code happening in here, and then there's client code happening in here. You might not want to do it this way because that exposes your whole system and how it works to exploiters. So you could segregate it into two separate services. But because I had some like shared stuff in here, and I was too lazy to separate it into like different module scripts with shared things. So I was like, screw it, I'm just gonna throw it all together in one service. And now I have a universal service that can be required by either a local script or a server script. So that's nice. Again, there's no right or wrong way to do it. And let me go ahead and play test this game here. So you can see the beautiful print log of the verbose loading happening inside of the output. So if I just open up this output all the way up, there we go. Look at all those beautiful prints going on with my verbose loading. So we got all of these systems being loaded first by the module loader on the server side. So we have all these setup scripts and services and stuff, and then we eventually we initialize the ones that need to be initialized. And then actually you can see that I have none on the server side that have a start function, which is kind of funny. And then on the client side, we do all the client stuff, and then we do the initializing on the client stuff. And then I actually have one that has a start function in it for mobile UI. So there we go. Look at that. All of it's nice and organized. And you know what's something else I forgot to mention is that you can prioritize in what order you want these modules to be loaded in as well. So let's say I wanted specifically, if we actually look at the first module being loaded, is my data service. I want the data service to be the very first module that loads in the game. How do I guarantee that the data service is the first one required? Well, if we look at my data service, I have an attribute on here called loader priority. So if you set an attribute, loader priority, and you set it to a number, the higher the number is, the higher priority it gets, and it will likely be the first one to be loaded. So I have my loader priority set to 9999 on my data service, and because that's the highest priority, that's the first one to be loaded. Now, if you don't have loader priority set on your modules, then they're just going to be required in whatever order they get collected by the collection service and get children from the container and that kind of stuff. But to guarantee the order of it, you can just throw that attribute on there. It's very useful. One more thing I forgot to mention is that there's also an ignore loader Boolean attribute. So you can set that on a module, and the module loader will completely skip over it on the client and the server. So if for some reason you had a container with modules in it and there's a particular module in there that you don't want it to be required, or something happened with it with the module loader, then you can just throw ignore loader on it and nothing will happen. It's also useful for like testing purposes. If you just need to temporarily disable some kind of service or module in your game, just throw that Boolean on it and you should be good to go. And that's about it for my module loader. It's simple and doesn't have much going on and gives you the creative freedom to structure the modules in your game however you desire. If you're interested in trying it out, again, there will be a link in the video description to grab it off the marketplace. Thank you for watching, and I will see you next time.